Okay, our first lecture for today is by Sarup Banskota, and it's called Digging Within Git. Enjoy.
Hello. It's my first time in Serbia, so first of all, hello Serbia, hello Novi Sad. As you can probably tell, I usually am found mostly in Asia. That's like my usual habitat. And in Asia, when we start conferences, there is like a little custom you do before you start. Usually you test the microphone, like, hello, can you hear me? But but apparently it's not that very, things just work here. So when I'm presenting a conference in Asia, I usually have it covered. Like I usually come with a few jokes or something like that for the time period where the laptop is being set up or the microphone is being set up. Unfortunately, none for you because you have everything covered. So I wanted to begin by thanking everyone for having me here. We'll be talking a little bit about Git as the slide says. And thank you organizers for making it so easy. In fact, usually, I was telling the guy I'm staying with in the same place, and then when I was on the way, I was telling him that it's my first day ever starting a conference. On the last day, the first talk, and usually that's a tricky one because mostly people are drunk the previous night, right? I can see look at him. It shows on his face, right? So you don't want to mess with drunk people on the first thing they're listening to in the morning. And the worst thing you can do to drunk guys and girls on the first talk in the morning is to talk about a subject like Git. And yesterday I was writing a bunch of slides, sitting in a cafe, and just scrolling Twitter, and then this thing showed up. Apparently 2 days back somebody made a little website about, oh shit, Git. And I will read that out for you. It says, Git documentation has this chicken and egg problem where you can't search for how to get yourself out of a mess unless you already know of the thing that you need to know about in order to fix your problems. So this was my story a few years ago. I was also new to a computer in the first place, and definitely to Git. And I had just started to write simple programs in my university, and somebody told me, try this thing out. It's called Git. It's very useful. And I was Googling, right? And the first thing I Googled was, one of the first things I read was it's a fast, scalable distribution revision control system. And that sounds like something out of someone's LinkedIn profile. And it was too much to grab at first. And although, of course, over time, once I started using it more and more, it started to make sense, and everything was quite useful. And once you kind of get the hang of it, you learn it the hard way that at the end of the day, Git is a stupid content tracker. And this is not me making it up. You can check up like man Git, and that's what it will say. So this talk is a little bit, it's not really about how to use Git. It's more about how Git internally works. And I will give you a little bit of background just to do a little motivation about why this is useful, why we should try to understand. So for me, I'm a designer. I'm actually not that much of a programmer, although I do program. And a few years ago, I was complaining about how design tools aren't, very, very nice. So for designers, we had a lot of problems collaborating whenever you want to collaborate on design work. And we don't have something like our GitHub equivalent, where you really have this social place where you can go and do your design stuff. And since we didn't have one, I decided to start helping create one, and I was involved with a project which basically tried to be a GitHub for open source designers. And while I was making it, there were two problems. I had to understand a bit of how Git works because that software was Git backed, and I'm a designer. That's short for saying I have a problem, I don't really know what's happening here. And I struggle with everything in Git, like that website. Whenever you want to do a merge, okay, I tried to do a merge once, and then it created a merge commit for me. Fair enough. Then a few days later, I made another merge, but this time there was no merge commit. So what happened? It's the same try kind of thing. A few days later, I wanted to do a rebase, and that happened because I somehow screwed up my project history, and one of the more experienced ladies I was working with said, you should probably rebase it and then send a pull request again. So, ego issues, I couldn't ask her exactly what a rebase is. I went and Googled it. I tried to do the best I could. And I rebased, and somehow all the commits in the history, and this was about 60 commits in a pull request, speak about bad practices, and all of them somehow there were commits she wrote, and they appeared there somehow, and my face was on top of her face on GitHub, and I really didn't know what was going on. So such stuff, they never made sense to me. And over trying to build this tool and fixing some of my own problems, I struggled and tried to understand how Git works, and I thought I should share it with you. So let's start. So the basic idea is in Git we have something called porcelain commands and plumbing commands. I don't really know why they are named that way, but that's how it is. Porcelain is like the front end sort of user facing, the commands that you are expected to use more often, unless you are scripting or something like that. And plumbing is what Git uses internally to, make those things happen. And you probably don't use plumbing commands on a day-to-day basis unless you are doing something with Git or you're trying to write a script or something of that sort. And I'm not very sure how much, in what depth or what kind of explanation I will need to do. But let's start with the basics. I will have to switch my. You can see. Another problem, side joke. When I was in Serbia, one of the issues when you come from Asia is I'm typically shorter. So every cafe I want to go and eat food in, it's like, hey, can you get me the food? And then my laptop is here, and I have to type like that. So I'm sure it's the same thing with the terminal. So let's make sure you can see it. More? Can you see? Okay. More? Okay. Good enough? Okay. So let's try just creating a repository. Let's call it Balcon. And would anybody tell me what is the porcelain command for creating a new, like how do you initialize Git within a repository? What would that be? Okay. So we did that. And so now here it's worth mentioning that most of Git's magic, it lies inside this repository called .git. And that's why my talk was called Dig In Within .git. And, oops. Yeah. And now let's try to see what's in it. So I will do, right? So there are a bunch of things inside it. And usually in your daily course of work, if you're doing software projects, making applications, you probably don't want to go in here and do things. This is only when you want to understand what's happening behind the scenes. So that's that. And you will see that that's the same thing. Now all of this is not really relevant to this talk because we'll try to keep it simple. We'll talk about the key concepts, after which you can always go back and construct other things from it. So the things we really want to worry about through the duration of this talk are the head file, objects, and refs directory. Okay. Okay, I'll just explain what is going on there. So at its core, Git is a persistent hash map. You give it content and it converts it to a hash. And then this hash gets thrown around. So that's basically what happens. Let's try to do something. For example, let's just say there's this plumbing command I'll introduce you to. It's called git hash object. And what it does is it takes some content and it converts it to a hash. So let's try to make one. Let's make something called pivo. And I will pipe it here. And we are taking it from standard input. Usually hash object expects a file, but we are taking it here. And you will see it returns you the hash. So this pretty much represents what's in it. And let's see what happened. I mean, we did something inside a Git repository, and we already initialized the Git repository, and so far we ran this command. So you would expect that somewhere there should be some, reference to it. So I will try to do this again. Actually, let's do. But really, nothing new is there. It's just what it was before. So what happened was we didn't persist it, and to persist it, we can do this write flag. And once we do that, we can actually look inside the objects repo, and you will see that a new file has been created. And there is a convention. If you observe this string here and this path, the first two characters have been made a directory, and the rest of the stuff has gone within. Now I'll introduce you to another one plumbing command. It's called cat file. And cat file is basically like some sort of inspector. You give it something and it will show you what's in it. So I'm just going to take the first few characters of this string here, and I will pass it to cat file. And it's, oops, sorry. I also need to pass a flag. So there are two commonly used flags. One is T and P. So if I use T, it's going to tell me that it's a blob. That's Git way of saying that's content, okay, something like that. And you might wonder, we wrote pivo, where did that disappear? I mean, it doesn't seem to show anywhere in the whole Git repository. So it's actually within this. This is. So what's happening here is Git cat file is almost like, think of it like some sort of doing a cat operation, but then it's looking inside what's in that Git object. So the content that you had sent pivo, it's now saved within this one. So let's look at what files we have again. And right now we have this. So let's go back. Yeah, so that's just a string, and you take any unique string, it's going to return you a unique SHA. That's another thing to note. And now let's try to visually do something. Actually, I wrote a little script before I came here, simple one. Let's run that. So I'm just going to, for the sake of simplicity, I will try and create a repository quickly. And you will see that I have created something called git repo, and that's what the structure looks like. So what's there? It's a directory called git repo, inside which there's another directory called Friday, inside which there are two other files, and at its root there's also another one called readme.markdown. And these are the files in this directory. There's no git initialized yet. So now let's try to enter this one, and we'll initialize git here. And as you can see, that guy has been created, and we'll just make a commit at this point. Let's just call it first for simplicity. So you have some information now. There's this weird string again, and then it says which files got added and so on. So that's the commit. Like, let's try to visually look at this. And what's in it? We don't know yet, so let's try to inspect. You have already returned this string, so I will take that and I will try to do a cat file with it to first see what type it is. And it says it's a commit, which tells us that that's how commits are represented. And then let's try to now see what's in the commit. What do you expect to see in the commit? Let's begin with that. Anybody? The name of the files? What would you expect? A diff? Mm-hmm. The content of the files. Any more answers? Okay, let's just stick with that. So we are going to look at what's within this, and we'll check. I'm sorry, it's a bit, yeah, but I think you can make out. It basically has what looks like a bit of meta information. It has my name, and it has other things like timestamp. And then there's something called a tree, and then there's the commit message that I specified. But there doesn't seem to be any reference to the files that I created, nor the content. So it's a bit funny. I will try to break this down for you. Now, what you see here, that is literally the commit. This is not meta information. This is literally exactly Git's commit. And what happened here is that each commit, it's kind of pointing to something called a tree. And that tree will think of a tree like some kind of directory. Trees can contain other trees, and it can contain blobs. Blobs are what I explained already. They are just pieces of content. And trees contain other trees, and you can navigate, just like, I don't know, like a file system. And let's try to inspect what's in the tree, right? So, by the way, I just noted down this here so that, like just the representation, the black stuff is the commit, and then this thing here, that's the tree for that commit. And now we'll try to inspect what's in that tree. So let's do, oops, keep doing it all the time. So if I check the type for that one, it tells me it's a tree, just like I expected. And we'll now try to see what's actually in it. And there you go. You see that there's a reference to a blob, and there's the file name, which you are familiar with, and there is also another directory within it. So let's try to visually represent this. What happened is, inside the commit, there is a reference to its tree, and inside that tree, there is a reference to another tree, which is referencing Friday, and there is a reference to this blob. And if we dig further, okay, let's see what's in the blob, right? So let's take some part of this string, and we are just trying to see what's in the blob. So first of all, let's do, to make sure that's indeed the blob we want. And now, woo, that's where the content of that file was. So what we had saved in that file is within this blob. So I will walk you through that once more so that we are clear. First, there's the commit, which is referencing to its tree. And that tree has reference to another tree, and it has reference to another blob. And the name of that file, which has that content, is actually in its tree. It's not in the file itself. There is no file which has, there is no standalone file. And the content of that file is actually within this blob. Okay, and you could also dig further. I'm struggling a bit with the size. Okay, let's clear this. So I'm starting with that commit again. And I found the tree of that commit. And now I'm just seeing what's inside that tree. And we already saw that there's a blob. Now let's try to go inside another tree. So let's try to do, and you see that tree has more blobs within it. So basically, the sort of like the structure of that directory that we had, it was now kind of replicated here in this tree structure. And then there are two blobs, and I think it should be obvious by now that if we check out what's in the blob, what do you expect? What would you expect inside a blob? Okay, cool. So that's fine. So that's our representation so far. Let's try to make another commit, just for fun. I actually memorized the string that I want to change so that the SHAs are the same. So we'll go inside Friday, and I will change the file called pivo to more pivo because we all like it. And it's been, let's call it second, right? So that's our situation at this point. And this commit has a hash, and let's And as you expect, okay, I think I messed up on the file name somewhere. But essentially what happens is that this commit now has a reference to another tree. And if you open that tree, you will see the same structure that we had before. And this structure is there in that fashion because we didn't really change the structure of our directory. All we really did was change the content of one file. Now let's try to visually understand this. I just hope I'm not going too fast or something. So we changed the content of just one file, right? So that's there. And why is that a new reference? Because that's a new file. It's new content, so it gets its own blob. And there's a new link to it. But there was one directory in our project, the Friday directory that you see here, which got referenced here. We didn't do anything about it in the second commit. So what do you expect would happen to it? Do you think we would create a new, like a new link with a new tree? Any ideas? Just link it, right? Exactly, it's smart. So it's just going to reuse what you already have. There's not going to be anything new there. I'm going to let it parse. That's what happened there. Okay, so we'll walk through this once more quickly so that the sequence is clear. I'm sorry if this comes across as boring to some people, but there was a commit. It's linking to a tree, and then there's another tree there and a blob. The blob has the content, and then there are two files which are linked to blobs in that tree, and there's a second commit. Okay, so at this point you pretty much understand at a high level what's happening in the background whenever you write commits. That's really all you need to know. Now let's think about how do you think when, let's say you change commits, right? You go, you check out to another commit and you want to see what's happening in that commit. So how do you think Git actually figures out that these are the stuff that you need to see on this commit? Like, would you expect there to be a diff mechanism? You must have heard of the term snapshot a lot, like when you do the Git stuff. I never got that. I mean, snapshot. What's this snapshot? Sounds like a photograph thingy, but not quite. This system makes it super easy for Git to track anything. So how Git figures out what content to include in any commit? Basically, you take whatever commit you want, and then you traverse from that point everywhere you can reach. So let's take first, you can reach here. From there you can reach here. You cannot reach here because it's an inverse direction. You can reach here. You can reach here. So this would be the stuff that's included in the first commit. Let's talk about the second commit. Where can you go if you started from the second commit? You could go here. You could go here. You could go here. You can't really go here, and so on. So a snapshot is basically just following the path wherever you can go, and that's really all there is. So no, you would go till the blob, and one. I didn't quite understand how you would go back to the first. Okay, later. Yeah, cool. That's why, I mean, it's a bad idea to do. Yeah.
What's the relationship between a snapshot and commit?
A snapshot, it's essentially what can you see on that commit. That's basically the snapshot.
Basically commit. Snapshot is this.
Yeah, and where can you reach? And basically, if you are at any point in your project history, you are on some commit, right? So what can I see at this point? What am I accessible? That's the snapshot. And the commit is just the representation for that thing in Git. Okay, let's talk about branching now. This is the second freakout that I had when I was tinkering. So right now our setup pretty much looks like that. There are two commits, and there's a branch master. So we'll just put a little thing there. And I think I will have to do this a little bit visually. But okay, so there are two things here. Let's talk about that first. So there is a branch master, and now you would wonder, where is this master thing? I mean, where is it saved? Because clearly we didn't have it in that objects area. There was no reference to it. We can verify. Oops. Okay, that's a lot to parse. But there is no reference, just trust me. And now we'll just go to refs. I will save you the trouble, and you will see this thing called heads. And that's where the reference to all the branches that you create, they are basically kept there. Let's create a branch, and then it will be more clear. So let's create a branch called fixes. And I will do the same thing. And you will see that it got there. For those of you who find it easier to look at it visually, maybe I can. Yeah, so all the stuff which was the Git object database, that's here. Ignore the info and pack for now, that's more for Git to make things quicker. But this is basically all the stuff that we were looking at. These are the objects we created. And the references, like the branch names, they are here. There are just two files with them. And one might wonder what's in it. It's just a simple text file. So let's try to do. And it links to something. I mean, you see another SHA. So let's try to see what this SHA was all about. Actually, I think I've seen this before. So if you notice that one, this is the same SHA here. So it's basically our second commit. But let's try it. Yeah, it's indeed that commit. So that's where. So what that branch file contains is a link to that last commit where it was standing, wherever it was pointing to. Then there is this famous thing called head. Everybody knows head. And if you just check out all the branches we've got two branches, fixes and master. And master is bright and green and nice, and fixes is not really. So where is this information contained about? Which branch am I currently on? That's another thing worth wondering about. So this is actually there in a file called head, and let's find it. There's this file head, and that basically contains, the reference to which branch is currently on. So let's do it. And you will see that there is a link to the current branch we are on. If you don't believe me, we can actually switch branches. So let's do. And you will see that the reference has changed. So next time, if you want to feel geeky and you want to change branches, you don't do git checkout thing. You know which file to go and change, right? Just kidding. Don't try it. Yeah, that's it. Okay, from this point onward, I will try to not do much of a demo. Otherwise, it's going to get a bit tricky. So I will try to use the visual representations. Okay, so we stopped at that point, right? We basically had two commits, and there was master and fixes, two branches. I think it goes away. Yeah, okay. So there are two commits, and there are two branches, and head is pointing to that master thing. Now, let's try to create a new commit. So we create a new commit third, and what would you expect to change with master and fixes? Would you think that would head change? We didn't switch branches, so would you expect head to change? No? Yeah, so head doesn't change. We didn't really do much with fixes, so fixes didn't change. So obviously master changed. And what happened was master moved and it pointed to the third commit. And head just moved along with master because it was already referencing to it. Okay. So now we want to switch branches. So what we did was we switched from, we were here before, we were on master, and I just did a git checkout fixes, and all that happened was the reference, the head now points to fixes. That's what it looks like. Let's try to clean this up a little bit, and it's the same reference. I'm just making it look nicer. Let's try to do a merge. So what we want to do is we want to merge those two branches, and this is a very tricky thing. I mean, what exactly did happen when I created a merge? So what Git does, it creates a new commit, the merge commit, which is very famous, and then it moves the reference of that branch up to that merge commit. So now both of those things are contained there. That's how a merge works. Till this point, it is fairly straightforward. Now let me ask you a question. So imagine that this is the merge commit, and we are here on master. And let's say I wanted to merge these two branches. I want to merge these two. So what would you expect would happen? Would we create a new merge commit and then, put the arrows there? Would we expect to do that? Yeah? Agree? So just to repeat the question, there's a merge here, there's that other commit, last commit on master, and I just want to merge these two. What would happen? I mean, would we create a new node here and just kind of merge it? That's what we would expect, but Git is smart. So it basically just moves that guy there, because think about what you're trying to achieve. You're just doing something that's already there. And this, my friends, is exactly what happens when you do a fast forward. And every time you see that fast forward thingy, this is what happened. Basically, that's Git congratulating you for saving an extra commit. Yeah, so that's that. Now, I think I'm going towards the end of my talk, and I would like to end by explaining how rebase works. That's quite interesting. So that's the scenario. Let's assume that's our scenario right now, and we would like to basically take this fourth and fifth and put it over second and third. That's how we want to maintain our history. So what we are trying to achieve is we want to take that guy and put it on top here. Now, how would we do that? I mean, you can't really, if you did anything to do with, if you change this link, you would be changing the parent. I don't know if I showed you that, by the way. So, oh, sorry, just a moment. Oops, I'm stuck. I'm a little stuck actually. I can't remove it? Okay, it's fine. I'll just explain this way. So I'm sorry, I have created a condition where I cannot go back to the other screen. But essentially, what you want to create is you want to take fourth and fifth and move them on top of second and third. That's what you want to achieve. And what happens is every commit also has something called a parent, and that's basically linking to the parent commit, the commit before it. And now if you were to change the link, you will be changing the commit itself, which is not fair because commit objects are immutable. So what Git will do is it will cheat. And what's going to happen is, I had slides for this, but maybe you can check them out later. Essentially, fourth and fifth, there will be two exactly same content commits, new commits created with new SHA and everything. And it will point to third and then point to fifth. So that's not this commit moving anywhere. The commit really stays where it is. There are two new commits created specifically for that rebase, and they will contain the same properties as these, and they will move on top of second and third. And now you can imagine if you move there, and this branch reference will move to the top. So there's no way to reach these guys anymore, because you've now gone to that branch. So once there is no way to reach a few commits, what do you think Git would do with it? Any ideas? Throw them away. What else could it do? So yeah, I mean, I heard somebody say it's going to keep them for a while, and somebody, I think I heard garbage collection, must be the C guys. And yeah, exactly. So that's what's going to happen. It's going to keep them around for a while and let it chill. And after a point in time, when it no longer needs them, it's just going to throw them away. Yeah, that's basically all there is to understand here. I had the last slide which said thank you in Serbian. I think, was it Haula or Havla? Hvala. Yeah, so Hvala. Thank you. That's all.